What's up, Raiders? Just want to talk to you today about our similar polygons and trigonometry unit in the distance learning for Odyssey-ware. And before we get into any specifics, I just want to say this is new for all of us. So don't worry about if you're struggling a little bit and if things aren't going perfectly smoothly. That's pretty understandable. But just make sure that as you're working hard, you're communicating with your teachers. So certainly send us emails, contact us on the Remind app, or when you're in Odyssey-ware working on problems, right on the screens of the problems you're working on, you can contact us for help. As long as you work hard and you communicate with us, everything's gonna be just fine. All right, so let's get into some specifics here. So the similar polygons and trigonometry unit. So I want to use this time to introduce trigonometry ratios. Now, I think a lot of students, when they see front and center on a calculator, these buttons that look like sin, cos, and tan, you go years and years and years without ever using them, so you just kind of have a tendency to assume it's some super complicated math concept. And so it tends to be pretty intimidating for a lot of kids. Well, the good news is, if you understand division, then that's all you need to know for background information in order to be able to make sense out of these trigonometry ratios. So this really just builds off of what we've done recently with similar figures. So for example, if I had two triangles that had corresponding angles that were congruent and side lengths that are in proportion, then we're going to have similar triangles. So for example, if this is a 30-degree angle, and we know the interior angles of a triangle have to add up to 180, so if this is 30, this is 90, then this one's got to be 60. Well, if we have a larger triangle, but it's similar to this one, also 30, 60, 90 triangle, then what's going to be true is their side lengths are not going to be congruent, but they'll be in proportion with each other. So for example, in this 30, 60, 90 triangle, if the length of this side was 4 units, then it turns out, based on the characteristics of a 30, 60, 90 triangle, the length of this hypotenuse would be double that, would be 8. Or from the other perspective, this side's half of that. Well, this triangle's a little bit bigger. So this side here, if this had a length of 7.5 units, then it turns out that the hypotenuse here would be 15. And again, because these triangles are similar, the side lengths are not going to be congruent, but they're going to be in proportion. So if I set up a ratio of this side length over this side length, 4/8, that would reduce to 1/2, or we could also, the decimal equivalent of it, 0.5. Well, do the same thing over here. Take the exact same combination of side lengths to make a ratio. I did 4/8, so following that pattern, 7.5/15. And it still reduces to the same 1:2 ratio, or 1/2, or equivalently 0.5. And this would be true for any smaller or bigger similar triangle I made to these 30, 60, 90 triangles. And so now we can kind of get into where we use those sine, cosine, and tangent buttons smack dab in the middle of a calculator. So the terminology we could use is we could say sine of 30 degrees equals 0.5. And if we did that in a calculator, first things first, you got to make sure you're in the correct mode. You have to be in degree mode. So you hit the mode button, and then you look right here. You're either in degree mode or radian mode. You want degree mode. So we're in the correct mode. So now we could type in, we could hit this sine button, sine of 30 degrees equals, and we get 0.5. Well, what the heck does that mean? So in everyday life, we have shortcut ways of saying things all the time. You know, LOL, laugh out loud. Well, sine is really just a shortcut way to say sine of any angle. I'll generically use the symbol theta. Sine of any angle is really just a shortcut way to say take the length of the opposite side and divide it by the length of the hypotenuse. So what the heck do we mean by opposite side? Well, if we have a right triangle, we know the two sides that make the 90-degree angle are the legs, and this diagonal side, this longest side, is the hypotenuse. Well, if we focus on this angle A right here, Well, if we look at things from the perspective of this angle, we have the hypotenuse, and then relative to this angle, you have two more sides that we haven't labeled. Generically, they're legs, but relative to this angle specifically, this side is on the opposite side of the triangle, and this side is right next to it, or the phrase we use is adjacent, which just means next to. So relative to this angle A here, this is the length of the opposite side, this is the length of the hypotenuse. So that's all sine is. It's not some complicated math concept. It just means it's a shortcut way of saying, okay, compared to whatever angle you're focusing on, in this case A, take the length of the opposite side and divide it by the hypotenuse. Well, in a 30, 60, 90 triangle, it always works out that the length of the opposite side is always half of the hypotenuse. So if this one is 20, and we don't know what this one is, I picked nice, neat mental math numbers here. It's going to end up being half of the hypotenuse. It's going to end up being 10. Well, if we didn't know that, we would generically call that x. So we could say sine of 30 degrees equals some unknown side length divided by the hypotenuse. Because that's all that sine is. It's a shortcut way of saying take the length of the opposite side compared to the angle you're focusing on, in this case the unknown x, and divide it by the hypotenuse. So now notice what we have here. We just have an equation that we can solve. We want to get x all by itself. We want to isolate that variable. That's our unknown. We don't know how long the side length is. Again, we know it's 10 from simple mental math, but imagining we didn't know what it was. It's being divided by 20, so the opposite or inverse of dividing by 20, multiply by 20 to get rid of that. So what we now know is this unknown side length x is going to equal whatever the heck 20 times the sine of 30 degrees is. And you can type that into the calculator exactly like you see that. So on your calculator, you can go right to 20 sine 30. And you don't need to do a degree similar than 20 sine 30. You don't even need to do the close parentheses in this case. Hit enter, and you get, which we already knew would be, 10. So x equals 10. So this is just a quick intro into what the heck those trig functions are. There'll be some more videos later talking about the other trig functions of cosine and tangent, but this is at least the starting point. Raider Nation.